your minor constituents, tend to keep the infrared radiation bouncing back down towards the planet. So you have a certain amount of heat is retained. And that changes over time, over many different time scales. There are a number of different factors that affect the climate. I said we talk about weather versus climate. Weather is like today it's raining, tomorrow it's sunny. It's it's what you think of as day to day, maybe over a week, the change in weather patterns. Climate is more long-term and it's more averaged over time. Like you live in a tropical or a subtropical climate or an Arctic climate. It's generally the patterns over seasons, how things change, and from year to year it's going to be pretty similar. The things that affect the Earth's climate on the natural side are how much sunlight we get. The sun's the main source of energy for almost all the processes that keep us going. Volcanic eruptions, the particulates from volcanic eruptions can cool climate over fairly long periods of time. And changes in the Earth's orbit, the way the Earth wobbles in its orbit at times can affect changes in climate, and it can do things like bring on an ice age. But in recent times, the times we're used to, as far as human culture, climate's been relatively stable, and we tend to have thought of it as a fairly immutable thing. Since the industrial age, since the steamship, we've started to burn a lot of stuff, and most of it is fossil fuels, coal, oil, natural gas, and wood products. All of those have byproducts of carbon dioxide, which is a major greenhouse gas. Also, the way we use the land and the way we do things. Agriculture, it's not known. Major constituent of global warming is methane, and that comes out of cows mostly and other agricultural processes. If you think of it, we eat so much meat now that the population of grazing animals is much higher than it ever was naturally, just because we produce them and maintain them. Changes in habitat and ground cover. When you grow plants, they bound carbon into their growing material, so it's a sink for carbon dioxide. Now, pay attention to this slide. Gases that contribute to greenhouse effect. Water vapor, that is the main greenhouse gas, but the water cycle is something that we don't affect that much. Our industrial processes, the way we inhabit the land, in terms of how much water vapor is in the air, it's not something that men affect that much. Carbon dioxide, we have a big impact on. Nitrous oxide, also a pollution byproduct. Methane, and CFCs are chlorofluorocarbons. Those are the things that you use for coolants in refrigerators. That contributes to both the ozone hole and has an effect on climate. The problem, some of these constituents, most of the talk that you hear about is about carbon dioxide, but CFCs have a very long lifetime in the upper atmosphere. So they can have an amplifying effect on climate issues way beyond the very trace amount that's in the atmosphere. There have been some international agreements that have limited the amount of CFCs that have helped reduce their impact, but some of the replacements that helped reduce impacts on the ozone hole still have warming effects. Gases that contribute to cooling, sulfur dioxide, that's one of the reasons volcanic activity can cause cooling in the climate. And particulates. Also, you think of particulates in the air like a sooty cloud. That leads to sunlight being reflected back out into space instead of getting to ground level. One of the things that led scientists to think that climate change might be an issue was the idea that, well, maybe all this burning of stuff since the 1800s, maybe it could affect the concentration of CO2 in the atmosphere. And a scientist named Charles Keeling, with other researchers, set up a research station in Hawaii. Why Hawaii? It was on a mountain, on a volcano mountaintop in Hawaii, thought to be a place where there wasn't a lot of industrial activity, very few pollution sources, It was sort of a pristine area to say, well, what's getting diffused throughout the atmosphere by man's activities around the globe. And you can see that from the 60s on, there's a pretty nice straight curve up of carbon dioxide in parts per million. It's almost linear. And since then, there's been an effort to, when ice forms over time, bits of gas are trapped in the ice. So there have been ice core studies to go back and try to get an idea of what the composition of the atmosphere was before we started taking data in Hawaii and other places. And you can see that about the time that people started to do a lot of burning industrially, that CO2 levels have spiked dramatically, as have nitrous oxide and methane. So this in itself is pretty good evidence that what we do as humans is affecting the composition of the atmosphere. And these few slides are to go through different levels. One of the problems with us coping with comprehensive problems that take a long time to evolve is that our lifespans are only, a very short time frame compared to natural systems. So something that happens over a number of generations, it's a little hard for us to plan for and accept and deal with. And climate change kind of hits all those problems where it's easy to forget about it and not notice the changes over the years. But you can see back that going back over the past 600,000 years, we are way out of the trend for the concentration of CO2 in the atmosphere. So the normal level is somewhere below 300 parts per million, and we're right now at 362. That's in 2006 on this chart, and the projections under different scenarios can go as much as doubling that within the next 20 years, depending on what we do. All right, now going much deeper in time, you can see that although this is a very high level of these gases for the past 600,000 years, it's actually not unprecedented in prior times. But you got to remember that 65 million years ago, we weren't around. That was dinosaurs. It was a very different and much warmer Earth with no ice caps and a lot more of the land covered with water. So the overview of climate science, what we know today, that greenhouse gases and temperatures are rising. Warming of climate system is unequivocal. There's not a lot of debate at this point. There's a lot of debate about precisely what that's going to do and what the impacts will be in particular places, but the overall concept is pretty well accepted in the scientific community and largely in the political and social community. Human activities have induced most of the warming over the past 50 years, almost 90% certainty of that. We have much better modeling. We understand the Earth system a lot better than we did 20 or 30 years ago, and we have much more confidence in projections of some of these impacts. And we can use these models to gauge the impact of a number of different control strategies or changes in the way we use energy and other things, and I'll get into that a little more. Temperature projections. The best estimate, given an assumption of a certain middle-of-the-road kind of strategy to deal with climate change, is between 1 and 4 degrees centigrade. And where that falls within 1 and 4 degrees centigrade has a lot to do with what the impacts are going to be. That's 3.2 to 7.2 degrees Fahrenheit.